This video is going to be a little bit longer just because I want to break down just the further expectations when submitting the classwork. I've just seen some various aspects of this, so I just want to be everyone to be clear on how we're going to go about doing this. So starting off, this was the do now of today, and really all I'm asking you to write down in your notebook, is the question and then your responses. If it's a multiple choice, just a quick copy and paste as you have it, as you can see with number 1 and as well with number 2. When we go down to number 3, there is need to be some work shown. So this is where I would like for number 3 specifically, where you see the work and I can see the line-by-line computation and how you arrive to your answer with the rationale because it asked for it. So now moving on with the notes page, if there's vocabulary box, we're going to just copy it down. You should be doing this prior to coming to class, so you can refer to it during class. Then we just go by doing example 1, having the stamp right after it, example 2, having the example after it, and then we do problem set A comes next in the book, and then problem set B. Of course, there will be more space provided to answer problem A and B, but this is just like a general rough understanding. And again, just kind of like here, make sure you show all your work. This way that I can see where you're at with this and how I can move forward and best support you as a teacher, as well as like showing credit. Because doing line-by-line computation actually will give you credit with this IA as well. Then we go into exit ticket, and that's what kind of what we're going to be covering today, right now. So this is how kind of my procedure of answering this type of exit ticket. I just go by, again, parentheses is the first, and inside the parentheses, it's not multiplication, not division, it's exponents. So I do 2 squared, which I know is 4, and then negative 1 times 4 is negative 4. Is that what we need? Yes, it is equivalent. Check off. Negative 2 squared, I know that is negative 2 multiplied by itself. Therefore, it's positive 4. So that's a no-go. Negative 2 squared, well, I know 2 is being squared, not the negative opposed to b. So it's negative times 2 times 2. Therefore, 2 times 2 is 4. Therefore, negative times 4 is negative 4. Good, that's the equivalent of what I want. And then here again, negative 2 is being squared. So we do that first, which is positive 4. Negative times positive 4 is negative 4. This checks out just as well. And so, in the exit ticket, you'll say A, C, and D, but in the work that you're showing and submitting, you're going to take a picture of that answer and response. All right, now we'll be moving forward. Number 2, so the grouping is absolute value, meaning anything that would become positive. So 3 squared minus 11, let's do the exponent first. 3 squared is 9 minus 11 over 2. This is a separate group, and because this is a separate group, I can solve it separately at the same time, simultaneously. So I can do that too. So again, left to right, like we discussed in class. So 32 divided by 4, that is 8. So now we just have 8 times 2. 9 minus 11, this is negative 2 over 2. Plus, again, this is a separate group, so 8 times 2 is 16. All right, absolute value of negative 2 is just positive 2. Any absolute value just leads to a negative. My apologies if this was not taught. And then square root of 16 is just 4. And so now we do not add, we have to divide. So 2 divided by 2, this is 1. 1 plus 4, our final answer is 5. I hope this cleared things up. Absolute value is another grouping. It means any number, whether it's positive or negative, the result will always be a positive. I should have foreseen this and shared it with you. My apologies. And so now we go to number 3. All right, we exponents first. There are 2 separate ones, so I can do them separately and simultaneously, all 3. So 5 squared, 25, divided by 5, times 4 squared is 16, all over 5 plus 5 squared, 25. All right, now I do 5 divided by 5, which is 5, times 16. 5 plus 25, that is 30. 5 times 16, 80 over 30, which I can simplify, cancel out both of the zeros. 8 over 3. And I understand students had trouble because you couldn't do a fraction. My apologies. But 2.6 is suffice just as well. And there you go. That's the exit ticket. See how the work is shown. You just take a picture of it with your phone and upload on Google Classroom. Just make sure you actually have it posted up. And so the other part of this video, this daily video, I'm always going to go through the exit ticket and then an example of tomorrow's lesson, just so you can generally get a glimpse of what's to come for tomorrow. You don't have to write any of this down. These are problems that are specific for this miniature lesson of such, and we'll have different ones for tomorrow. So if you're interested in what to come, just stick through. So I notice we have 4x, 2x, and 5x. Both of these have the same variable because they both have x, and because the exponent, this is 4x to the first power, 2x to the first power, and 5x to the first power, they all have the same variable and the same exponent. These are the ones in which we can combine the like terms. I like to just make sure, put them in the correct left to right order, not least to greatest, just left to right, and just group them as such. If better, put parentheses together. Now this is 2, it's a constant to the first power, and -7 to the first power. They both have the same constant and the same exponent. So variable or constant and the same exponent. So now I can combine them. 4 minus 2, again, left to right. 4x minus 2x is 2x. 2x plus 5x is 7x. And then 2 minus 7 is -5. And there we go. I'm not going to answer that question. So we then have our stamp. We're going to write our stamp in our class with whoever they may. We will find out. What do you think? +5, we do. I'll give you the opportunity to think of a stamp. And +5 if you have a really good stamp that we can share with the class. And here are some questions that you can consider for this example. How do we combine like terms? What do we need to identify when combining like terms? Can we add and or subtract constant and variables together? If so, how? If not, why? Alright, so now we're going to go to example 2. Simplify the expressions and identify the values of A and B. And right here we have the expression -1/2 times the quantity, that's where the parentheses come in, -6x plus 2y, plus 4/6 times the quantity of negative 6y plus 12x equals ax plus by. So because I have these coefficients outside the parentheses, I instinctively know to distribute both terms inside of the quantity. And this is how they will appear as such. Because the coefficient is outside the parentheses, I'm maintaining integrity by leaving it out. And because the 6x is inside of the parentheses, I'm keeping that term in. And notice I'm not adding these values because it's a negative 1/2. I'm still using the negative 1/2 as you see here as being multiplied by 2y. Now because it's positive 4/6, I'm going to put that positive 4/6. That's we know going to be multiplied by negative 6y. Again, positive 4/6 all over 12x. And because this equals an equation, I'm gonna keep it with us. My pad. Now we multiply out. Negative 1/2 times 6x. I can just rewrite it as negative 6x over negative 2. Negative 1/2 times 2y. So this we can also turn into a fraction, which is just 2y over 1. That's kind of what we did with here, 6x over 1. And now we have negative 1 times 2y, so that's negative 2y over 2, or minus 2y over 2, same thing. 4/6 times negative 6y, put it again in a fraction form, 4 times negative 6. That is going to lead us to be negative 24y over 6. 4 times 12x over 6. Well, I know 4 times 12 is 48. 48x times divided by 6. And again, it's going to equal ax plus by. So now we can combine, simplify further. Negative 6x divided by negative 2, that's positive 3x. Negative 2y divided by 2 is just negative 1y, or just negative y. Negative 24y over 6, well, 24 divided by 6 is 4 times, so negative 4y. And if you didn't catch this earlier, if I can have your attention above here, because we have the one denominator that's being multiplied by that same value denominator, it can actually just cancel out. And so we would just have 4 times negative y, which is negative 4y. Same situation here. 6 and 12, they're both divisible by 6. So here, what's remaining is 2. What's remaining is 1. What's 4 times 2 is 8. So it'd be 8x. Or if we look at here, 48x divided by 6, that is still 8x. And equals, still we continue writing ax plus by. So now we combine like terms, looking at the same, if they have the same variable and the same exponent. So because there is none that exist that are physically shown, we can assume it's 1. Put all the variables with the same exponents together. Usually we go x's and then y's, just like the alphabet. Negative 4y, negative y minus 4y. Now we can add them. 3x plus 8x, 11x. Negative y minus 4y is negative 5y. And you're right, I should have included ax plus by in both of these. Okay. And so now when I scroll down just a bit, I can compare 11x minus 5y equals ax plus by. Therefore, a must equal 11 and b must equal negative 5. Because it's negative 5 here, b must be negative 5. If it was a positive, then it would be positive 5. So that would equal b. And that's what we solve for this type of a problem. Usually they could do some fun things like, once you solve for a and b, what is 3a? So you just do 3 times the value of a, which is 11, which is 33. Or even extending it, what is 2 times a over 3b? There's a lot of extensions we're going to go with this, but this is pretty much at what far as we're going to go for today. So thank you for your time, and just again to recap, when you're submitting your work, just make sure you have both examples with the stamps that are included. Make sure your exit ticket is also shown, work is shown and submitted, and it's everything in organized fashion as you see here. Thank you for your time and have a great rest of the day.